Hello dear friends, welcome to my channels. Today's discussions is Feynman path integral. Okay, Feynman path integral. Okay, so friends, I think that you have watched my first video where I discussed Dirac proposals. Okay, so what actually Dirac proposed? You have to understand that. Okay, so these equations we know. Okay, so I have already explained that this is the path integral. Okay, so Dirac proposals. Now I will discuss that what is the meaning of these equations. Okay, so what is the meaning of this equation in RHS? RHS means this portion. You can see this portion. I will discuss this portion RHS. Okay, so particular path connecting xi ti means initial initial path, initial distance, and initial time, and xf tf must be chosen to compute RHS. Okay, left hand right hand side, we are already dealing with a scena- scenery where we take both x and t. Okay, we are talking about events, right? So that's an improvement in a sense. That is the spirit of it. If you deal with events, if you ask questions involving events, that is the proportionality. Number one events is, what is the meaning? Proportional. Okay, this is the mean, should mean. Okay, and makes sense only classically, and this equation makes sense classically. And why? So this is the questions. Okay, answer: a path must be classical part. Okay, this answer: a path must be a classical path. Classical part. Let us see why that is so. X is additive. Okay, capital X is additive. Additive along the path. So this is another observation is X, capital X. So we are trying to answer why that part classical, why classical path. Okay, now the question is classically, sense is classical, why classical path. Okay, this is the why classical path. So Sx is additive along path. Okay, so Sx is additive along path. Let us draw a diagram. Okay, I draw a diagram, and this is t, and this is x. Okay, so this is x and y, and let's draw. So it is ti xi and xf and tf. Now slice. Okay, you could slice the entire time interval like t1. Okay, it is the t1, and another is t2, t2. Okay, t1, t2, t3, and this way. So the corresponding you have x1, x2. So you basically you are dividing the entire path it into small segment x1 to x2, x2 to x3. Okay, now we discuss additive doing path. Sx is, what is the meaning of Sx? Sx is additive along along path. Okay, so Sx is additing along path. So Sx equals to S x, okay, x tilde equals to integration ti tf dt l x comma x dot comma t. Okay, so Sx can be written this way. So it is, as you slice it, as this you slice entire time, so you can write this way: ti t1 plus t1 t2 up to plus dot 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 up to n term and l. Okay, so this can be written as a del I1 plus del 1 2 plus dot 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 up to. Okay, and last term is, you can say that del n comma n plus 1. It is called action action for the nth segment. So this entire, if you look, go back to Dirac proposal, this. Okay, go back to Dirac proposal, this. Okay, so what is the Dirac proposals? Let's start. This is my Dirac proposals. Okay, matrix element written as you can replace is thus by the sum of segmentize of action. Therefore, that would be product of those many phases. So, therefore, even these discussions we conclude that, okay, even these discussions we conclude that xf f comma tf xi comma ti, yeah, this is the, this element is equals to, we can say this way. Okay, so you can write this way, x1 t1 and xi ti. Okay, so this way we can write. Now recall completeness relations. Okay, recall completeness relations. What is the completeness relation is that dx x comma t and x comma t. I have already discussed this operator. Okay, this is the identity operator. Okay, so now we can say that because each, so when you write it as a sum of the segment, while the species of the action then becomes the product of phase, then each phase according to reversing Deluxe proposals. Okay, this proposals is called, this proposal name is Deluxe proposal. Okay, this proposal is the Deluxe proposals. For it will become the matrix element of the corresponding segment, right, at the matrix elements for the corresponding signals. Okay, so we can write this equation as, this is called, okay, this is the equation number 1. So Deluxe proposals I have already discussed. And now with completeness relations, any given instant of time, entire x kate of forms a complete basis, so in with the respectively integral dx. So one could write this way, xf comma tf xi comma ti could be written as dx1 dx2, so dx dx1 and dxn minus 1, and it is xf comma tf and xn minus tn minus, and it is up to xi x1 t1 and xi ti. Okay, it is the inner product, so it can be written this way. So the recall the completeness by the completeness relations. Okay, this is called deluxe this is called deluxe proposals. Okay, this proposal is called deluxe proposal. Okay, when you do that integration, the integral will produce, so these have x1 to xn minus 1 are integrated about the full range, but here x1 to xn minus 1 are some very specific points, and one does not know are if priority here x1 and xn minus 1 are not same. So this equation is called, this is the number 2. Number 2. So 1 and 2 can be same only classical limit. Okay. So my equation 1. Okay. What is my equation 1? Let's see. Let's see my equation 1. Okay. Yeah, this is my equation 1. Okay. This is my equation 1 and this is my equation 2. So 1 and 1 equals to 2. Okay. 1 and 2 can be same if classical limit if h bar tends to 0. So this is the called stationary. The path chosen in is the classical path. So the path chosen is the classical path. So it is stationary phase argument. It is called stationary phase argument. So Feynman suggestions. Now we will go to discuss Feynman. So this is Feynman suggestion. What is the Feynman suggestion? Let's start to discuss. xf comma tf equals to ti plus epsilon and xi comma ti. This is equals to I divided by h bar capital S x tilde. Okay, so this way. So x lower bar is the classical path connecting to infinity close points. Okay, x lower bar, this is the x lower bar, meaning of the x lower bar. I will write each term. This is the classical classical path connecting xi comma ti and xf comma tf. Okay, so this is the classical path. Okay, so now we can say what is the epsilon. Epsilon is infinitesimals. Okay, I write infinitesimal. Okay, epsilon is infinitesimal. Okay, let me draw a diagram. So this is my diagram, and this way we can say, you can say this way. So this is the way, and this is a tf. Tf is equal to ti plus f is ti. Okay, so and this is xi and this is t. Okay, so what about the finally separated events? That we know that when we go, you say these equations in the finally separate, we see this is the equation. In here you can see that it is the x tilde. Okay, in the Feynman, in case of Feynman, everything is tilde, x1 tilde. Okay, so for finally separated events. Okay, now we will discuss finally separated events. That is xf tf xi ti equals to limit n tends to infinity. Okay, limit n epsilon tends to ti tf minus ti. Okay, n epsilon is equal to tf minus ti, that is integration product of j equals to 1 to capital N minus 1 d xj. Okay, this is the way, and e to the power I h ti2. Okay, ti to tf dt l x comma x dot comma t. Okay, note it does not depend on capital N, right? So ideally speaking, just like the concept of integrations, you should in n times then do certain operations calculation, and that will only give you an approximate result for the matrix element, and you should be taking n going to infinite limit. Okay, Dirac proposal modified by Feynman. So write this matrix elements in terms of the phase. Okay, you have to remember matrix in terms of phase. Okay, phase where action is sitting, then these 2 points must be infinite, similarly close to each other. If n tends to infinity, then each matrix corresponding segment becomes infinitesimal segment becomes infinitesimal. Okay, each matrix corresponding segment becomes infinitesimal, then you can use. Okay, so let me discuss that where constant. So friends, I give some little bit idea about the Feynman path integral, but I need a lot another class where I will discuss Feynman path integral. So it is it is very large topic, so I discuss it is part wise, chapter wise. So please check my total chapter whatever I have done proposals and Dirac meaning, and I show deluxe proposals, and after that Feynman suggestions. Thanks for watching. I hope you enjoy my video. Please check my total work.